If you walk onto any major construction site today, you see a masterclass in physical logistics. Massive steel beams swing into place with millimeter precision. But the moment you look behind the scenes, that physical coordination dissolves into digital chaos. Most property and construction enterprises run on an operational baseline that is entirely fractured. Teams rely on highly specific, isolated software programs that do not communicate, leaving critical data trapped into disconnected silos. This diagram shows what that looks like. On the extreme left side, we have a cloud of messy source material. Loose emails, disconnected CAD drawings, isolated spreadsheets, and raw site reports float in a void, failing to connect with the rest of the business. This fragmentation generates severe operational friction. Every step requires manual handoffs. Compliance audits turn into forensic investigations, and getting an accurate view of portfolio performance across these inputs is nearly impossible. True enterprise automation is impossible as long as data remains trapped in these native, unstructured formats. Solving this requires an intermediating abstraction layer, a centralized system that sits directly between raw legacy programs and front-end workflows. This architecture acts as a universal translator. The center 5-tier operating layer captures chaotic left-side inputs, filtering them systematically. Passing through that stack organizes the information. On the right, these inputs transform into clean nodes mapping directly to active projects, precise budgets, and insights. We are going to reverse engineer exactly how this works, starting from initial data ingestion at the base all the way up to deploying secure enterprise AI at the top. Adopting this architecture moves an organization from passive data storage to an environment where every record actively updates the state of the business. The first step is capturing data without disrupting the tools teams already use. Here are the systems and integrations. On the right, APIs and inbox rules capture data from established tools like Salesforce and Procore, feeding the central layer. With real-time synchronization, original tools stay in place while data flows into a unified structure. Once that data is ingested, it undergoes normalization. Instead of isolated records, discrete data points are organized into a contextual graph, bound by standard identifiers. For example, an inbound email links to a verified contact, which then maps to an opportunity, a project, and RFQ documents, sharing one operational context. Raw inputs only become useful when they are normalized and locked into a reliable, interconnected business context. Once the data is structured, it has to move. The architecture shifts from static storage into active process alignment. This dashboard models business operations as concrete stages, tracking exact roles across distinct phases. Following the project owner's top lane, we see the process moving linearly from initial project intake directly into scope definition and resource planning. In traditional operations, ownership is ambiguous. Handoffs occur in chaotic email threads, and accountability vanishes when a task leaves someone's desk. The operating layer solves this through automated, context-rich handoffs. When the construction manager finishes scheduling work, the system triggers downward dependencies, notifying the design lead to create drawings and finance to estimate costs. Speed means nothing without accuracy. A process cannot advance to the next phase without validation. This is handled by approval gates. These are hard policy-based roadblocks. Notice how the QA gate and budget gate will not open until specific required approvals are registered. Because every action happens within this environment, real-time status visibility is automatic. Live metrics are pulled directly from active workflows. A workflow is only as effective as its visible boundaries, clear ownership assignments, and enforced handoffs. Accelerating an operation without systemic controls is a massive risk. In fact, automation without governance creates an absolute enterprise liability. This framework shows how governance as code works. Access controls and permissions are baked directly into the operating layer itself. It operates on the principle of least privilege control, ensuring users only interact with data relevant to their role. Automated policy enforcement intercepts compliance violations before they can execute, acting as an invisible management layer. Administrators manage this from the Governance Center on the right, which provides real-time visibility into active policies and pending requests. In physical asset industries, absolute traceability is required for regulatory compliance and dispute resolution. To guarantee that, the system generates complete, immutable audit trails, logging every action, approval, and data modification permanently. True automation requires an underlying foundation of trusted, controlled, and accountable governance logic. Feeding raw, unstructured enterprise data directly into a large language model guarantees hallucinations and security breaches. This graphic demonstrates why the 5-tier architecture is the mandatory prerequisite for artificial intelligence. By funneling inputs through the central stack, data is structured and filtered through permissions before it ever reaches the AI model on the right. The AI is restricted by the exact same governance rules as human operators. This hardwires access enforcement and accurate citations into the outputs, preventing unauthorized data extraction. High-stakes decisions still require human-in-the-loop workflows, ensuring the AI functions as a powerful assistant rather than an autonomous executor. Deploying enterprise AI is the final output of this multi-tier architecture, made possible only by first establishing rigorous data integrity. This diagram tracks the macro lifecycle of an enterprise adopting this architecture. The final stage establishes a continuous optimization loop, as shown by the bottom arrow. A connected operating layer allows businesses to monitor bottlenecks and iterate on workflows without rebuilding their underlying IT infrastructure. Implementing this layer shifts a physical world business from reactive data survival to proactive, systemic evolution.